Okay, dear students, in previous session we have seen some properties of addition of matrices and some properties of scalar multiplication of matrices and some more properties of multiplication of matrices. Some few properties have been left out that we will see first, and then we will be doing the problems on exercise 3.2. See here, now we are going to see some properties of multiplication, some two important properties we are going to see now. See, the multiplication, under multiplication, the matrix, it is not commutative. That is, if you multiply two matrices A and B, it is not necessary that it should be equal to B into A. AB should not be equal to, it is not necessary that it should be equal to B into A. See, I have taken two matrices A and B. Let me multiply now A and B. First row with first column, 1 into 0, 0, plus 0 into 1, 0. Now here, 1 into 1, 1, plus 0 into 0, 0. Now here, 0 into 0, 0, plus minus 1 into 1, it is minus 1. Now here, 0 into 1, 0, minus 1 into 0, 0. So this is equal to 0, 1, minus 1, 0. This is what I have got it for A into B. Let me find out B into A. B is equal to 0, 1, 1, 0 and A is equal to 1, 0, 0, minus 1. Let me get now B into A. B into A is equal to, multiply these two. See, 0 plus 0. First row with second column, 0 minus 1. Here, 1 into 1, 1, 0 into 0, 0. Second row with second column, 1 into 0, 0 plus 0. So this is equal to 0 minus 1, 1, 0. So here AB is not equal to BA. See now, next one it is. See, two matrices has been given. While multiplying two matrices, you are going to get now zero matrix. With the law, what it is telling, even though if you are multiplying two non-zero matrices, you may get a zero matrix. That is what we are going to check. While you are multiplying two matrices, if you are getting zero matrix, it is not compulsory that both the matrix should be a zero matrix or else one of the matrix it should be a zero matrix. It is not compulsory like that. That is what we are going to see now. See, let me multiply A into B here. 0 into 3 plus minus 1 into 0. Now 0 into 5 plus minus 1 into here 0. Let me take the value 3, 5, 0, 0. It is not a 0 matrix and this is not a 0 matrix. Minus 1 into 0, it will become 0. Now second row with first column, 0 plus 0. Now here 0 into 5, 0, 2 into 0, 0. So now I have got 0, 0, 0, 0. It's a 0 matrix. Even though I have multiplied two matrices which is a non-zero matrices, but I have got a zero matrix. This is what this law is saying. Zero matrix as a product of two non-zero matrices. See exercise 3.2, the first problem. Three matrices has been given A, B and C. Everything it is in 2 cross 2 matrix. We have been asked to find out A plus B, A minus B, 3A minus C, AB and BA. See in exercise 3.2 also, all the elementary problems are only there. See, these are all the problems has been given only to make you to be very frequent as well as very familiar with the operations of matrices. The addition, subtraction and multiplication. These are all the operation has been taught to you. You should be familiar with these things. That's why these problems have been given. These are all very easy as well as the elementary problems. We should have to add A and B. See, A plus B. The corresponding elements has to be added. 2, 4, 3, 2. Add with 1, 3 minus 2, 5. Add the corresponding element. The first row, first column, that element has to be added with the first row, first column element. So, 2 plus 1, 3, 4 plus 3, 3 minus 2, 3 plus minus 2, 1, 2 plus 5. So, this is A plus B. Same like that you can do A minus B. Let me do 3A minus C. C, scalar multiplication. This is a scalar element. Scalar element has been multiplied with the matrices A. 2, 4, 3, 2. And minus C. C it is minus 2, 5, 3, 4. Now first do the multiplication and then subtract with this. 4 3s are 12, 3 3s are 3 2s are minus 2, 5, 3, 4. Now subtract these two. 6 minus of minus 2. So this will become plus 2. 6 minus of minus 2, it will become plus 2. So 6 plus 2, 8. Here 12 minus 5. 7. 9 minus 3. 6. 6 minus 4. 2. So this is 3A minus C. Now let us do the fourth one. A into B. Just a multiplication between two matrices. 2, 4, 3, 2. This has to be multiplied with 1, 3, minus 2, 1. See, for multiplying, the first row has to be multiplied with the first column. That has to be written it up as first row, first column element. And first row with second column, you have to written it up as first row, second column element. So like that. So the corresponding elements has to be multiplied. 2 with 1. 2 into 1 and 4 to some minus 8 here. So this has to be written up as a first element and first row with second column. 6, 20. Now second, that's all, it is over for the first row. Second row with the first column. 3 minus 4, 2 to some minus 4. Here second row with second column. 3 to some 9, 2 to some 10. Now see this value, it is minus 6, 26, minus 1 and 19. This is AB. So these two you try it out, A minus B as well as BA. Now see this, here also it is the second problem. Here also it has been given, you have to add these two matrices. The corresponding elements has to be added. The first, this element has to be added with this element. So cos square x plus sin square x. Here sin square x plus cos square x. Here sin square x plus cos square x. Cos square x with sin square x. You know the trigonometrical law. Sin square x plus cos square x is equal to 1. So this is equal to 1, 1, 1 and 1. That's all. Remaining problems in this second question, everything it is for addition of matrices as well as multiplication of matrices only. So you can try it out that. This is a third question in exercise 3.2. We have been asked to find out the products of the two matrices. See, two matrix has been given to you. This is a 2 cross 2 matrix and this is also a 2 cross 2 matrix. So these two are equal. Number of columns in the first matrix, it is equal to number of rows in the second matrix. So we can start multiplying. Before we are going to start multiplication, we should have to check first the number of columns in the first row, whether it is equal to number of rows in the second column or not. Now you start multiplying the first row with first column. A into A square, plus B into B square. Now first row with second column. First row with second column has to be entered in first row second column. So A into minus B minus AB and B into A plus BA. Now see here, first row with first column, second column, it is over. Now second row with first column and second column. We should have to do it now. Minus B into A, it will be minus BA. And then A into B plus AB. Second row with first column, it is over now. Second row, second column. Minus B into minus B. So plus B square. A into A plus A into A square. So this is equal to A square plus B square minus AB plus AB, it will become 0. Minus AB plus AB, it will become 0. Here also A square plus B square. And so we have done the multiplication between two matrices. Now see here, it is a 3 cross 1. And this is 1 cross 3. See, these two are equal. We can start multiplying now. The first row with first column. The first row only one element and the first column only one element. Only these can be multiplied. It has to be written it off in first row, first column. 1 into 2. That's all. And first row, second column. See here, if you want, you can write it like this. 1 into 2. And first row with second column, 1 into 3. First row with third column, 1 into 4. So first row, if some more elements are there, that also has to be done. If some more rows, if it is there. So only one element it is there in the first row and only one element should be there in second one. So it has been multiplied like this. Now second row with first column, second column and third column has to be done. Second row with first column. 2 2s are 2 into 2 here, 2 into 3 here, 2 into 4 here. And third row with first column, second column, third column. 3 into 2, 3 into 3, 3 into 4. Now you can write this as 2, 3, 4, 4, 6, 8, 6, 9, 12. So this is the way you can multiply these two. Now this is a 3 cross 3 matrix. Here there is no need to think about anything. Here also 3, there also 3. We can start multiplying here now. First row with first column. First row with first column. 2 into 1 plus 3 into 0 plus 4 into 3. 2 into 1, 2 plus 3 into 0, 0. 4 into 3, 12. I have written it up here. Now first row with second column. So 2 3s are minus 6 plus 3 2s are 6 plus 4 into 0, 0. Now here first row with third column. 5 2s are 10, 4 3s are 12 plus 4 5s are 20. I have it done. Now second row with first column, second column, third column. 2 1, 2 2, 2 3. I have to fill it up now. So 3 plus 4 0, 4 into 0, 5 3s are 15. Now 3 3s are minus 9, 4 2s are 8, 5 into 0, 0. Second row with third column. 15 plus 16 plus 5 5s are 25. Now third row with first column. 4 plus 0 plus 18. Now 4 3s are minus 12, 5 2s are 10, 6 into 0, 0. Third row with third column. 20 plus 20 plus 30. 6 5s are 30. Now see while writing here, it is 14 minus 6 plus 6 will become 0. Here 42. Here 18, minus 1, here 56, here 22, minus 2, 70. So we have multiplied these two. In this third question, remaining some two problems are there for multiplication. You have a practice about these things. This is a fifth problem in exercise 3.2. This problem it is for to get the practice in scalar multiplication. 3 into A. The scalar 3 has been multiplied with the matrix A and the scalar 5 has been multiplied with the matrix B, and then these two has to be subtracted. So now 3 into A. The scalar multiplication means the scalar has to be multiplied with each and every element of the given matrix. So 3 has to be multiplied with each and every element over here with A. So 3 into A while doing it. So 3 into 2 by 3, 1, 5 by 3, 1 by 3, 2 by 3, 4 by 3, 7 by 3, 2 by 3. Now multiply this 3 with these elements. While multiplying it, 3 into 2 by 3, 2, 1 into 3, 3 into 5 by 3. Here 1, 2, 4, 7, 6, 2. Now 5b. 5 into 2 by 5, 3 by 5, 1, 1 by 5, 2 by 5, 4 by 5, 7 by 5, 6 by 5 and 2 by 5. Now this 5 has to be multiplied with each and every element inside over here now. So 2, 3, 5, 1, 2, 20, 35, 30, 10. Now, so 3a minus 5b. This is 3a, this is 5b. The corresponding elements has to be subtracted. 2 minus 2, 3 minus 3, 5 minus 5, 1 minus 1, 2 minus 2, 4 minus 20, 7 minus 35, 7 minus 35, so minus 18, 6 minus 30 and 2 minus 10. So this is the way how to calculate the scalar multiplication. And then see this problem, the seventh problem. We have been asked to find out the matrix x and y. We have to find out the value of x and y such that 2x plus y has been given to you like this and 3x plus y has been given to you like this. These also has to be matrices only, x and y. See, like normal linear equation, how you will be solving the linear equation, according to that you have to start solving it here. And according to matrix operations, addition and subtraction, scalar multiplication, these are all will obey associative law, as well as the commutative law, as well as the identity matrix. Everything it will be satisfying. But only according to multiplication of matrices, it is not obeying the commutative law. So that you should have to keep it in your mind. Now here, see the first equation, it is 2x plus 3y is equal to 2, 3, 4, 0. Let me take this as a first equation, and 3x plus 2y is equal to 2 minus 2 minus 1, 5. Let this be a second equation. Now, see, you have to solve this. Normally, how you will be solving the linear equation? So, this equation can be multiplied with 3, this equation can be multiplied with 2 to cancel x. Or else if you want to cancel y, this equation can be multiplied by 2, this equation can be multiplied by 3. So, 1 with this I am going to multiply it by 2, So I will be getting 6 over here. This I will be multiplying it by 3. I will be getting 6 over here now. So 4x plus 6y, which is equal to. Now this is 2 into this value. That is a scalar multiplication. If it is scalar multiplication, each and every value has to be multiplied by the scalar. So 2 2s are 4, 6, 4 2s are 8, 0. Now the second row, it has to be multiplied with 3. Now 3. The scalar 3 has to be multiplied with this matrix. Now subtract this. While subtracting, this will be minus 5x, this will become 0. This is equal to subtraction between two matrices. The corresponding elements has to be subtracted. So 4 minus 6, 6 minus of minus 6 plus 12, 8 minus of minus 3, 11, 0 minus 15. See, you can, or else you can write this matrix over here minus this matrix, you can write it, and then you can subtract, and then you can write it over here now. So here it's a scalar, it can be taken it up into this side. 1 by 5 minus 1 by 5 into minus 2 to 12. According to scalar property, you can bring this over here now. 11 minus 15. So this value has to be multiplied with each and every value over here now. So 2 into 1 by 5, 2 by 5 minus 12 by 5 minus 11 by 5 minus into minus 15 by 5, 3. So now if I substitute x value in any of these equations, I will be getting y value. Now let me substitute this x matrix in any one of this equation. I can get the value of b. Let me take the first equation. 2 into, see the first equation, x it is 2 by 5 minus 12 by 5 minus 11 by 5, 3. 2x plus 3y is equal to 2, 3, 4, 0. So do the scalar multiplication, it will become 4 by 5 minus 24 by 5 minus 22 by 5, 6. Plus 3y, which is equal to 2, 3, 4, 0. Now I should have to get the value of 3y. So 3y is equal to, see matrix addition only, this can go on that side. 2, 3, 4, 0 minus 4 by 5 minus 24 by 5 minus 22 by 5, 6. Now this has to be subtracted. Normal subtraction, you can subtract these two. 2 minus 4 by 5, 3 minus of minus 24 by 5 and 4 minus of minus plus 22 by 5 and 0 minus 6 minus 6, this will be. So 6 by 5 39 by 5. Now here 42 by 5, here minus 6. Now this is 3y value. You have to get from this y value. From here you have to get y is equal to 1 by 3. This 3 while it is going in this side, it will become 1 by 3 into 6 by 5, 39 by 5, 42 by 5 and minus 6. So 1 by 3 multiply this scalar value, each and every value inside over here. So 1 by 3, 2 by 5, 13 by 5, 14 by 5, minus 2. So this is the value for y. So we have got the value of x now. We have got the value of y now. This is the way you can solve two equations, matrix equation, and then you can get the value of two matrices. Okay, dear students, till this we will complete it on today's session. We will see the remaining problems on exercise 3.2 on the next session. Thank you, students.